All right, hello, welcome back. So we're starting, keep going on Unit 8 right now. We started with a couple problems yesterday on working with the trig functions, and now we're on, finish up the notes on page 2. So yesterday we talked about whatever you do with algebra terms, so factoring and distributing, and some of this appeared in your homework, that you can also do with trig functions. So on one of these we factored, we took a GCF out. On the other one we made common denominator, just like fractions stuff. So on some of this, it says factor this sort of stuff. Now, honestly, I wouldn't even factor this stuff. This one. All right, because when you see this, when you see a squared and a 1, I want to look at my yellow sheet. Okay. It is absolutely fine. We can factor it and that's not a problem, but I think that's going to be a little bit more work than going straight to the yellow sheet. Now we talked about yesterday, you have, when you start seeing squares in 1, you want to start looking at here, and it's obviously not the 1 over stuff. So we're going to skip that, not that. We have the Pythagorean identity. So we have secant involved in this one. So I'm just going to write down here so you can see it. So 1 plus tan squared u equals secant squared u. So that's what's on your formula sheet. So I want secant squared of the variable, so u or x, it doesn't matter which one, and I want to subtract 1. So I want to move this 1 to the other side. So if you can visually see it, great. If not, just go through the motions and make sure it matches up. Okay. So while it is possible to factor this, I wouldn't do it. No offense to anyone who would, but it's going to be a lot more work. Then I have secant squared of u or x, so I can just change this to an x. And that matches what I want. So I'm back to my one term of tangent squared u, or x or whatever. Okay, so done with that one. Now, this next one, example 5. I have like the 3-term trinomial, 4 tan x squared times tan x minus 3. So you can factor this, so you can treat it like 4x squared plus 1x minus 3. So you can treat it like that, and then after you get it factored, plug the tangents back in, or whatever trig function you have back in wherever you have x. Alright, so I have 4x, so 1x. I want to multiply to a 3, so I have a 3 and a 1. So it's going to be a minus 3 and a plus 1. So that I get 4x, and that I get minus 3x, and that equals my middle term of just 1x. Alright, so here are my factors. 4x, 4 tan, 4x minus 3 and x plus 1. So that means, so I plug in tan. So I have 4 tan x minus 3, and I have tangent of x plus 1. Alright, this is just, it asks you to factor it. So we're done with that. We don't have to do anything more than just the factors. So it's just treating it like so kind of just throw out the tangents for a second, factor how you normally do it. If you wanted to do grouping, you can multiply to a negative 12, but add to a positive 1 and do grouping with that with minus 4 and plus 3. Just kidding, other way around. And then factor it that way. You can do grouping also, but then again, just throw the tangents back in when you're done grouping. Now, this one here, cosecant x, cosecant squared x minus cotangent x minus 3. This is not possible to do like it is. So I need to get either cosecants, transform them into cotangents, or cotangents into cosecants. And what I'm going to do is say, okay, this is squared. I'm going to look on the yellow sheet for something cosecant squared. On the yellow sheet, so again, I'm not looking at the top box, not this one. So cosecant squared, I can replace it with what it is equivalent to, and nicely enough, it is cotangent, 1 plus cotangent squared. So I'm going to plug in 1 plus cotangent squared x, and then I have the rest of it minus cotangent x minus 3. Okay, now it's just kind of simplifying a little bit, nothing to distribute. I can drop the parentheses. I have cotangent x squared x minus cotangent x, and then I have the 1 and the minus 3 to combine, so minus 2. And just like we did with the tangent, once it's all in terms of the same trig function, I can treat this like x squared minus x minus 2. Alright, so I have my parentheses, minus 2 plus 1, and then throw cotangent back in. So cotangent x minus 2, and then cotangent x plus 1. Now, of course, you don't have to treat it like x squared like that. You can just do it with cotangents right away, but if you want a little trick to look like stuff you're familiar with, just kind of take the cotangents out of it. That's it for today. Finish up those notes. Talk to you soon. Bye.